In this video, we are going to explore the concept of visibility and reachability. Let's look at a few facts that we already know. Every name we have exported so far through the export keyword or through an export block, these things were visible in the importing translation unit. They were visible because we could instantiate their objects, we could access the names and really do things with them. Some names in your module-based code are reachable. Okay, so this is a new word, reachable, but not visible. But what does this mean? A name is reachable when you can't explicitly mention its name in other translation unit, but it can be accessed indirectly. But how do you access something indirectly? We're going to see an example in a minute, but keep this in mind. Anything visible is reachable, okay, because you can really use it, so it is reachable, but the reverse is true. You may have something that is reachable, but not visible. I know these things may be confusing you, but let's look at an example, and all this is going to become very clear. Here we have a module, math.ixx. The name is math, as you can see here, and we are implementing our things inside namespaces because we already know how to do that. We have a class point living in a namespace, and you see point is not exported. Okay, this is something, if it is not exported, we want to be able to use it in other translation units that import our math module here. That's something you already know. But look what we have down here. We have another namespace block. Okay, the function is exported and returns a point object, but the point class itself is not exported. So what do you expect to happen if somebody calls the generate random point function here? The body of the function is not really important. The important thing is that it returns a point. If you want, you can learn about these random device things. It is a feature in C++ to help you generate random numbers. And in this case, we are generating doubles. And if you want to learn about this, you can search about the random header in the C++ standard library. So let's say C++ random header. Let's say random header. It was introduced in C++ 11. And it has a few functions to help you generate random numbers. I think we are using this in our code, MT19937. We are using this to generate numbers. You can read about this if you want. I won't be showing you everything in a course like this. You should have the capability to go in and learn things by yourself. And this is how you're going to become an independent developer. Again, coming back to our point, the main point here is that we are returning a point, and point is not exported. Let's go to the main CPP file that is going to be using our math module. Okay, point is not visible, so we cannot create its instance. If we try to run this code here, it is going to give us a compiler error. But notice what we can do. We can call the generate random point function, which is going to return a point. But notice that C++ is clever in that it won't be mentioning point here. It will be using auto to let the compiler deduce the return type. If you say point here, you are going to get a compiler error because you can't mention point. But notice that we can really do things with the point object that was returned by this function here. We can print it out. We can get x and print that. You see, we can call methods on this object even if the class was not exported. And this is what we mean by saying that this class is reachable. Okay, it's reachable because you can call things on it if you try to access things indirectly using the auto keyword, but you can't explicitly mention it in other translation units. This is what we mean by visibility and reachability. Something is visible if you can explicitly mention it and use its methods. For example, mention the point name here, so it is visible, but it can be reachable without being visible. Okay, make sure you understand these things here. Let's go back to the facts that we talked about earlier. Every name we have exported so far was visible in the importing translation unit. It was visible because types were explicitly exported from modules. Some names in your module-based code are reachable. We just saw this, but not visible. Okay, point in our code here is reachable, but not visible. A name is reachable when you can't explicitly mention its name. We can't mention point, so it has the possibility of being reachable in other translation units, but it can be accessed indirectly. Okay, we are accessing the point class indirectly through the auto keyword. Anything visible is reachable. Just because something is reachable doesn't mean it is visible. These are the points I wanted to make clear here. Now that you understand this, we can head over to our IDE and see these things in action. We can hop over to Microsoft Visual Studio. The project is 4813, visibility, reachability. Let's go back to GitHub and see the files we have for this project here. We have a README file, the main CPP file, and our math interface file. If we go to the interface file, it is going to be containing our classes. We have a point here which is not exported. We have a generate random point function inside this namespace. Let's copy this and go back and create the math interface file as we always do. So let's say math. It is a module interface file. So let's say math with lowercase and add this. And we can put in our content right away. And after we have this, we will have to grab the main CPP file, which is going to use it. Let's copy it and come back to our files and put the content inside the main CPP file. We have to enable C++20 as always. So let's go to properties, go to language, enable C++20, and we need to go to general and scan sources from module dependencies. Let's enable this. Click apply, click OK, and if you try to build this, let's see what happens. The build is going to go through. You see the compilation order, the header unit, math, and main CPP. This is what you already know. So let's see what we can do. We can call the function here. This is what I want you to see. If we go back into our interface file, you see that the point class is not exported, but we can use a returned point and call methods of it. And this may be confusing to people, but this is how C++20 is wired. It gives you the ability to use things indirectly if you happen to need that in your C++ programs. But one thing I want you to see, let's first run the application to see it running. You see, it is going to be printing things. One thing I want you to see is that you can't say point. You can't say math point, for example. Let's see if we try to build. Okay, it's going to say P is an undeclared identifier because you can't really mention this point name. So the only way we have to do this is through the auto keyword, and the compiler is not going to mention this, but internally it is going to know that what return is a point. And the guys, the designers of C++ went for enabling this kind of thing. I personally don't find a use for this. Maybe you will find a use for this, but it is a feature you have to learn about. That's why I am mentioning it here. But if you try to mention point directly by instantiating a point, you will get a compiler error because point is not visible. It is reachable, but not visible in this case. This is something I want you to see. Let's try to build to see the compiler error. It is going to say identifier not found because point is not visible in this case here. Now that we have seen this, we can try and use this with other compilers that we have access to. Here we have a README file with instructions on how to compile for GCC and Clang, and I will be going through these instructions with you. If you want, you can skip ahead and watch the next lecture. Because you want to be learning something new, it will just be me pasting these commands to generate a raster binary that we can run on our system here using these compilers. Let's start with GCC. So copy the command and go to PowerShell, and let's do ls to see what we have access to. This is a good practice. Main CPP math.ixx. We can generate our header unit for IO stream, put in the command, and we can generate our math interface file. Let's do that. And what do we have here? You can see that we have a bunch of errors here. Again, this is one of those cases where importing header units for old header files may be a problem for different compilers. I want to go into this problem I want to try to really go further, trying to use this header unit with this project here. What you can do if you don't want to deal with this is to revert back to old includes. For example, we can go back here and include IO stream in the global module fragment and go back to main.cpp and say include. And it is going to include IO stream here, and you can build it. If you build with Visual Studio, it is going to build right away, no problem. Okay, build succeeded. But we can even build this using GCC. Notice that we don't need to generate a header unit because we are including. So all we need to do in this case is to just compile the interface file. Okay, so let's do that. Copy. And before we do, we should clean up before whatever was left in by GCC. And let's see if we don't have any object files. We don't. We can now compile our math interface file, which is not importing anything. So we don't need any pre-compiled BMI. If we run this, it is going to work. And if we go down and put together our rooster binary, let's see what we get. It is going to come together and we can run it and see our output here. But this is a hack we just did, so I am going to revert back to importing and see what we can do with Clang. I think Clang can do it in this case, but we'll see. I don't really keep this information in my brain. At this point, let's go back and revert back to importing IOStream. You just saw the problem that I wanted you to see. So let's say import IOStream here. And we need to go back to main.cpp and import IOStream as well. We can change this. So let's say import IOStream. And we need to put a semicolon at the end, I guess. Now we can hop over to Clang. And before we do, let's clean up the mess that was left in here. So let's ls and remove any object files and remove. We don't have the GCM. We do. So this is clean now. Let's remove rooster and we are clean. We can hop over to the command prompt and save the files that we have, because with Visual Studio you have to save manually. I think there is a setting to autosave, but I don't want to go through that right now. Let's see. Random is throwing weird errors, reverting to including it. So this is what I got when I tried this earlier. Let's see what we get now live. Because we are learning, we should do these things together. And if we face a problem, we'll see what we can do. The header unit is generated. Let's go back and see if we can compile the PCM for our module file. If we do that, it is going to go through. Notice that it is using imports. This is something that failed with GCC. So this is the first time that Clang does something that GCC can't do. And you figure out these things by playing with these compilers. Don't be afraid of these commands. They are there to help you out. Let's copy and put in the command to put everything together. And now we have a rooster generated. Let's do the IR. And we have our rooster file right here. We can run it. Let's do rooster and it is going to print whatever is needed here. Let's clean up again. So we should remove any PCM files and remove any object files and remove the rooster binary that was generated by Clang 16 on Windows. We hop over into our Docker container, which is working in this project. Again, we will be pasting in these commands. Copy and put this in. Hit enter. It is going to generate our header unit. Copy this and generate the PCM for our math interface file. Put it in. The PCM is going to be generated. Don't worry about these warnings here. So let's copy and generate the main object file. And what do we have here? Oh, we didn't copy from the start. Let's do that. Be careful with your copy and pasting. Put it in. It is going to go through. Let's go back to the start. Copy the command to generate the object file for our interface file. Put this in. It is going to go through. Copy the command to generate the binary. Put it in. And we are going to generate our rooster binary inside our Docker container using the Clang 18 compiler. Let's do lsalh on Linux. We should have our rooster binary here. Together with many object files that we have generated, you can see our PCM files. This is really cool. Now we can run rooster and it is going to do whatever it does. And this is really cool. This is all I had to share in this lecture. The main concept is reachability and visibility. Something is reachable when you can't explicitly mention its name, but you can use it indirectly like we are doing here. So the point class is reachable in this case, but it is not visible because you can't explicitly mention its name like we are trying to do here. I am going to stop here in this video, and I will see you in the next one.